Welcome to the Jac tutorial series. In this first episode, we'll walk through what a full-stack AI app looks like in Jac. From data model to front-end, all in one file. The example for this episode is a to-do list app with AI-powered categorization. You type a task, and the AI assigns a category. Work, personal, shopping, or house, for example. It is a small app, indeed, but it covers all the key pieces: data model, AI integration, backend, and front-end. Here's a typical project structure for this kind of app. You use a Python backend, you use a React front-end, a Docker config, of course, 14 files and 4 languages in total. That's about 233 lines of application code. Jac takes a different approach, however. It expresses the same app in about 45 lines of a single language. In Jac, front-end, backend, and AI logic live in one file with one type system. When the front-end calls the backend, it looks like a regular function call. The compiler generates the HTTP boundary automatically. Jac transpiles to the standard Python on the server and the standard JavaScript on the client. Every PyPI package works for you, therefore. NumPy, Pandas, Fast API, and every npm package works too. The output is regular Python and JavaScript files you can inspect, debug, and integrate into your existing projects. When the frontend calls a server function, it looks like a local call. The runtime generates the HTTP request, serialization code, and a response parsing code. The same type definition exists on both sides, so the client receives a typed object instead of a raw JSON string. Here's a complete app. One file, one language, data model, AI categorization, backend, and frontend all in one file. Let me walk through each section directly. This is the data model. On the right is the traditional version, a SQL alchemy model, a Pydantic schema, and a migration script. In Jac, you declare the fields, and the runtime handles the persistence automatically. This is AI integration. The traditional approach uses prompt templates, API calls, and a response parsing. In Jac, the function signature, name, parameter types, and return types all serves as the specification of the prompt. The return type constrains what the model can output. These two functions are the backend. The traditional version uses route decorators, dependency injection, and schema conversion. In Jac, marking a function as public makes it an HTTP endpoint. Parameters becomes the request automatically, and the return value becomes the response. The traditional React version redeclares type in TypeScript and uses fetch calls for the API. In Jac, the UI calls server functions directly, with the same types on both sides. The runtime handles the network layer. That's about 45 lines in one language and one file. Data model, AI, backend, and frontend. The same functionality as the 14-file version. Jac includes several built-in tools. The /doc endpoint serves a Swagger UI, auto-generated from your function signatures. Every public function appears with its requests and response schema. The /graph endpoint visualizes your data as nodes and edges. It is very useful if you're inspecting or debugging your data model. The toolchain also includes a built-in MCP server. With one command, AI assistants like Cloud Code or Cursor can validate and run Jac code against a real compiler. There are also exportable skill files that are basically version-matched reference guides that can teach your AI assistants about Jac. There's also Jac GPT, an AI assistant that understands Jac syntax, concepts, and common patterns. It's connected to the same MCP server, so it can validate codes and search the documentation in real time. So the core idea is that the complexity of databases, prompts, API layers, and front-end backend glue moves from your code into the runtime. You describe what your app does, and Jac runtime handles the implementation details. Over the next several episodes, we will cover each piece in depth. Syntax, graphs, walkers, AI, server, front-end, authentication, and deployment. By the end of this tutorial, you will go from a single file script to a Kubernetes cluster. See you in the next one.